When we perform a test, there is always the possibility that you can end up in the wrong conclusion, even though your entire procedure is correct. Yes, it's it's an arbitrary concept. I want you to think of a test strip. After COVID, we all know how tests work. So let's say COVID, UTI, any of those, pregnancy, you go and get a test strip from a pharmacy. Is that test conclusion 100% accurate? No, right? Flu, same thing. Even if you get a negative result, it doesn't mean that you don't have it. There is a chance that the test could go wrong. During COVID time, if you read articles, often, or sometimes, I shouldn't say often, you might have encountered falsely reported, falsely identified, falsely concluded. So a test was done, but it gave an incorrect result. Same thing could happen with a statistical test, even though you did everything right in terms of the procedure. So assuming you did the procedure correctly, there are two types of error that could happen. So you have some actual conclusion and you have a prediction or hypothesis that you have. Two possibilities. You do not reject null. Or you reject null. That's pretty much how we write our conclusion. That's what we did in chapter 4. The actual scenario, do not reject null. Reject null, same two possibilities. If you don't reject the null, no effect. If you reject the null, significant effect. Don't forget that part. So, if you say no effect, nothing there, so we can call it a negative in terms of testing. Yes, no effect, no disease, nothing's wrong with you, evidence, nothing. Otherwise, you can call it positive. I'm writing it this way because it's easy to understand. You have predicted, your test concluded that there is no effect. In truth, there is no effect at all. Did the test do a good job in predicting that truth? Reality, negative. Test result, negative. Did a good job, no error. There is an effect in reality, but you concluded there is no effect at all. My scenario last semester was going through a lot of issues, symptoms, So in my mind, I'm thinking, maybe I had flu, COVID, so I did all kinds of tests. They all came back negative. Of course, I could have had something else, but hypothetically, perhaps the test gave me the wrong result. So whatever negative I read is a false negative to your equation. So let's say you are pregnant and the test says you are not pregnant, made a mistake, yes? So in that case, it made an error, it's a false negative. We call this type 2 error. Nothing's wrong with you. Let's take another case. You don't have flu. Nothing's wrong. You do a test and ends up concluding that you have the flu. Is it a true positive or a false positive? It's a false positive. Take a guess. I call that type 2. This has to be type 1. Last case. In truth, let's take another example. You have a UTI and you get a test strip. It also concludes the same thing. So did the test make a mistake? It did. No, it didn't. So no error. This is an abstract concept, but essential because, yes.
Does type 1 error have to do with the alpha levels and the type 2 with something else? Because like we went over this in my stats class last semester, and then I have the chart right here. And the professor that was copying it down had different symbols in both boxes.
Very good, Justin. You read my mind. That's exactly where I was going. This is an abstract concept, but we need it because it's related to alpha, the level of significance. Again, it hurts my soul to see P listed instead of alpha in your textbook. But then I had problems with the textbook from last semester. Maybe I'm just picking. No, still, it has to be alpha. So your professor would have used the notation alpha. Yes? I use alpha as well. The example that we just did called it P, the significance level. So alpha is level of significance. That's what I introduced. You all read. But now that I've explained the decision errors, type 1 error, or the probability of making a type 1 error, assuming the null, in the sense from the very first day of classes, I said when we perform a test, we are going to assume that there is no effect and see if the evidence takes us away from that null. So I'm going to assume the null. Under the null, what are the chances that you would make a type 1 error? In other words, a false positive. That is nothing but level of significance. Is it possible for us to have no error or errors at all? we are dealing with uncertainties, random stuff. Is it possible to have no errors? No, it's not feasible at all. But one can try to reduce the error. Yes, when a test is approved, they look for the value of alpha to see if alpha is really low, this value really low. But you can't make that 0 and make that 0. Not going to happen. There's always a probability with which you make a mistake. From a mathematical or theoretical standpoint, since we can't reduce both of them, we try to fix one at a level that we are comfortable with, and then make the other one 0. Yes, I can't reduce both of them, but you have to make adjustments. So I'm going to fix this as long as I'm comfortable, and then make that 0. Now, this is a job of, an like me, who's going to do the derivation simulation and say, in this case, this is the appropriate test that you should use, which is why I said it's in the test. Going back to previous chapter, every problem that we did, we chose an alpha. Yes, alpha 0.05, alpha 0.01, alpha 0.1. In other words, I chose a value that is comfortable and fixed this. Theoretically, when we do a test, whatever test that we will do is a test that a nerd like me concluded would give 0 type 2 error. If you fix this, I say comfortable with me. So an abstract concept, but how do we come up with a test and ask you to do research using the test? This is how. We ask you to pick a value, countable value, and I did all kinds of math and derivations, and I'm telling you that if you pick this, this will become 0 for a given scenario and the appropriate test. One second. Right?
Yeah, because it depends on the test. Sometimes would you rather have a false positive?
It depends on the test, and this is easier to minimize, to reduce theoretically speaking, than that, which is why we let you all make the choice and say, here is the test, and if you choose a small alpha, you're not going to make a type 2 error. Good. Keyword being using the correct test. So,
I was gonna ask if it would work vice versa. So like if you were to get a value for the false negative, would you try a false positive to it, or would you mostly just work for false positive?
we can, your question is very similar to what I asked. We can, but from a theoretical standpoint, if you fix this, reducing that to 0 is not going to be easy. We kind of go against our assumptions that we are making, because we are assuming the null, and we want to see how wrong, how far we can go away from the null. So based on the construct, this is the easier way, appropriate. So we will always fix alpha. Are we clear?